Jai Hind students, today we are taking periodic classification of elements from class 11th. So in this chapter we will study about what were the early attempts of the to classify things. Before starting the early attempts, we need to understand why do we need to classify things. We classify our things at home also. Your mothers also classify things at home. Why it is required? What is the requirement of this kind of classification? We classify things to make our life easy, for our comfort, so that whenever we require any kind of thing, we can take it from its place. So classification you can see in your school library also, like your library teacher keeps all the English notebooks and books in one almirah, he keeps maths in other almirah or at other place. So he has also classified things according to the he has also classified books according to the subjects. In the same way, as we have 118 elements are known to us, it is very difficult to understand, to learn physical and chemical properties of 118 elements. That is why we need to classify these elements also. So at present we have 118 elements as known to us. All these have different properties. Out of these 118 elements, only 94 are naturally occurring. The earlier attempts to classify the element result in grouping then known elements as metals and non-metals. Later further classification were tried out as our knowledge of elements and their properties increased. So if we see the classification, so one by one we will take classifications given by different scientists. So first of all we will take Daubernier. Daubernier in 1817, Daubernier was a German chemist and he tried to arrange the elements with similar properties into the group. So if a group of elements having similar properties is there, we can learn their properties very easily. So Daubernier, what were the attempts of Daubernier? He identified some groups having 3 elements each, so he called his group a triad. Daubernier showed that 3 elements in a triad were written in order of increasing atomic masses. The atomic mass of the middle element was roughly the average of the atomic masses of the other. As you can see on the screen, the first triad was lithium, sodium, potassium. So atomic mass of sodium was roughly an average of atomic masses of lithium and potassium. Similarly, atomic mass of strontium, that is the second triad, it was roughly equal to average of the atomic masses of calcium and barium. So he could make only 3 groups. Daubernier could identify only 3 triads of the elements known at that time. Hence, this was the drawback of Daubernier, that other elements cannot be grouped in the form of triad. After that, Newland has classified the elements in the form of octaves. Octaves means 8. He made group of 8 elements. According to him, Newland has given a Newland's law of octave. He has given law of octave. What was that law? In Newland's octave, the property of eighth element was similar to property of first element. Every eighth element has properties similar to the first, as in the notes of music like sa, re, ga, ma, pa, da, ni. Again, eighth one is sa. Okay, so as eighth note is the same as it was the first, in the same way every eighth element had properties similar to the first, like hydrogen, lithium, beryllium, boron, carbon, nitrogen and oxygen. So these were arranged according to atomic masses. So this Newland has given octave law of octave. There were limitation of law of octaves also. The law of octave was applicable only up to calcium. After calcium, it cannot be applied on other elements. Other elements do not possess properties similar to that of the first. It was assumed by Newland that only second drawback and second limitation of Newland's law of octave. Newland assumed that only 56 elements exist in the nature and no more element would be discovered in the future. Third limitation was, but later on several new elements were discovered. In order to fit elements into the table, Newland adjusted two elements in the same slot. He also put some unlike elements under the same note. Cobalt and nickel are in the same slot. For example, cobalt and nickel are in the same slot and these are placed in the same column as fluorine, chlorine, bromine, which have very different properties than these elements. Like cobalt and nickel are metal, whereas fluorine, chlorine, bromine are non-metals and these are halogens. As there were drawbacks, many drawbacks were there in limitations were observed in the limitations were there in the law of octave. So next attempt that was done by Mendeleev, and Mendeleev arranged the elements in the form of columns, in the form of rows and columns. So Mendeleev has arranged elements in the table and that was called as Mendeleev's periodic table, that we will take in the next lecture. So today we have finished this here only. We are going to finish today's lecture at this place only. Mendeleev's periodic table will be taken in the next lecture. So thank you so much, and if you have any doubt you can write your queries in the comment section. Thank you so much.